everyone, and thank you for joining us for another wonderful talk by the OWASP Nova chapter, and specifically Abhay. But before we get into that, Mike's going to introduce our speaker. And before we get into that, I do want to mention that we are having the upcoming OWASP Global AppSec Conference coming to DC. That will be October 30th and 31st for the official conference. And then there's also training from November 1st through training from November 1st through November 3rd. So if you're interested, please look at more information. I'll put the link in the chat, but it's globalappsec.org, or specifically dc.globalappsec.org. And there's going to be a bunch of great speakers. Possibly somebody who is currently in the chat might be a speaker there. We're still waiting for results, but he spoke at the last one and he was wonderful then, and he might be again. But yeah, also we don't have any connection to the conference at this point, so please, as much as we would love volunteers and support and all that, we don't manage the conference at this point. So, if you ask us for tickets or ask us for volunteer opportunities, there's nothing we can do to help you out. So, anyways, Mike, can you take it away?
Sure. Thanks everyone for joining, and we're really excited to have Abhay speaking tonight. He's someone that I've actually taken his training before, seen him speak multiple times, so really excited to have him speak, and thank you for doing this. So just a quick introduction. Abhay is obviously a cybersecurity expert, entrepreneur, and worldwide speaker and trainer on all things AppSec and CloudSec. He's the founder and chief research officer of AppSec Engineer, and looking forward to hear him talk about supply chain.
Thanks so much. Thanks, Mike. Thanks, Ben. Thanks, Mike, for making this happen. I think it was a little last minute that I reached out to you, said that I'm in the area, but thanks so much for making this happen. I really appreciate it. Always like to talk to as many OWASP chapters as I can when I travel around. So it's always nice to do this. Anyway, today, let me just start to share my screen and then we can get started.
Perfect. And yeah, if any of you in the chat or anything have any questions, just please feel free to put them in there, post a comment, and we will be sure to address them as we can. So without that, I'm going to stop talking.
All right. Thanks so much. And yeah, so the talk today is called Fantastic Supply Chain Vulnerabilities, kind of going by the whole Fantastic series in Harry Potter. So Fantastic Supply Chain Vulnerabilities. So the talk is largely going to be stories and attack stories that will obviously lead to some ideas of defense. So that's really what it is. In fact, most of these scenarios and vulnerabilities that I will be talking about, or exploit scenarios that I'll be talking about, I cover as part of training on attacking the supply chain at Black Hat and so on. So this is something that I've picked from there. So I've picked up some of these things from there as well. Just to give you an idea, Mike introduced me, but outside of that, I actually run two companies. One is an application security services company called V45. And more recently, I started a training platform on AppSec called AppSec Engineer. Now, some of you may be using it already. We have a lot of people from the AppSec community using it. The OWASP community is using it as well. Aside from that, I do a lot of work in the automation space, whether it could be cloud security automation. It used to be DevSecOps. I started doing DevSecOps even before it was DevSecOps, and in fact, one of my first ever trainings on DevSecOps was at OWASP AppSec in 2016, and that was also in DC. So I have a lot of fond memories of that. That was my first ever OWASP training at a conference. It was like, I think we had like a pretty large room and they had 60 people or something, and it was a very interesting training that we did for 2 days. It was a lot of fun. Aside from that, I've authored a couple of books. This was a long time ago. I used to be in PCI. I've authored a couple of books, but outside of that, I've largely been involved in the scaling the AppSec side. So I started off in the offensive AppSec space, but then I've started moving largely towards scaling AppSec in terms of DevSecOps or cloud security or what have you. Now, today I'm going to be talking about supply chain, and the obvious reasons for this is pretty straightforward. Right, supply chain has become a pretty huge issue, and it continues to be a pretty huge issue as far as all of us are concerned. A lot of time, effort, and money is being spent by private organizations as well as governments in order to address this issue, either through regulation or some other sort of evangelization or something like that. But supply chain security still is a very complex and burning issue, and I think it's going to be that way for a few years at least. So, definition of a supply chain: network of individuals, organizations, resources involved in creation and sale of a product. This is a typical supply chain. You're talking about your standard supply chains when it comes to your manufacturing supply chains. But when it comes to software supply chains, these are components, libraries, tools, and processes used to develop, build, publish a software artifact. Right now, this was straight from a Usenix paper co-authored by Dan Gear. So one of the things that you will see is that it's not just libraries. Most of us think of supply chain as libraries, but it's not only libraries. It's the tools, it's the process, and throughout the generation of a software artifact, all of it is typically supply chain, right? So this is really what a software supply chain consists of. And if you look at just a standard applications supply chain, you're dealing with a lot of things to consider, right? So if you look at this mind map that I created, this mind map kind of gives you, like, I mean, I'm not saying this is a comprehensive mind map across the board, but just this mind map should give you an idea of the size of the problem that we're dealing with, right? So we're looking at server side libraries, server side code, server side components, third party components, what have you. It could be plugins, it could be frameworks, it could be libraries. You have client side. Again, you have a whole bunch of things on the client side as well, right from the JavaScript widgets that have caused pretty huge security incidents in the form of mage cart and so on, as well as your I think probably seemingly unending series of JavaScript libraries that every project seems to have. Outside of that, you're also dealing with CI, which is another massive ecosystem in itself. That itself is probably, in fact, in our training on attacking the supply chain, I pretty much focus like three-fourths of a day on CI based attacks and exploits. That itself is a pretty huge ecosystem. Containers, of course, no prizes for guessing that containers is a pretty huge feature of the supply chain, and it has caused some serious issues. It continues to cause serious issues when it comes to container related issues. Of course, the cloud has its own set of supply chains, Kubernetes, own set of supply chains. So it's a pretty large ecosystem, as you can see. And we've more than once been hosed by this, right? We've had major issues all over time. We've seen this is right from I've taken incidents from 2000, the early 2000s to now. You'll see that we've had a series of issues related to the software supply chain. NotPetya, which was a very publicly well-known supply chain attack, was also because of a tax software getting compromised, one of the updates for a tax software in Ukraine getting compromised, and as a result of which you had a massive contagion, which is NotPetya, which was wiperware. Aside of that, you've had the solar winds, you've had several other issues that have happened. I'm not going to get in too deep into this. Most of you have seen some of the stories here. CodeCov was a big one because CodeCov was a CodeCov is used by most of our developers to build stuff and test it for code coverage and so on. And their bash uploader script was compromised, and it started sending just a single line of code was changed in a 1,800 line bash script, and it started sending environment variables to the attacker controlled servers. And of course, it's literally that simple. So supply chain attacks have been there. They're going to be a part and parcel of any software that we're going to be building. It's already there and probably going to be building as well. It's going to only increase in its importance. So today's agenda, I'm going to be talking about three stories. I do have two demos as well. So three stories is what I'm going to be covering. Three stories around different vulnerabilities at different stages of the supply chain. So one during the pre-commit phase of the supply chain, then one during the CI phase of the supply chain, and the third is a Kubernetes story that I'm going to be talking about. So at three phases of the SDLC with completely different supply chain implications. So I'm just going to be talking about these three stories. That's all I'm going to focus on. That's all this talk is going to be focused on. And of course, we have demos. I'm going to be using our labs from AppSec Engineer to show you some of these demos as well. So let's talk about pre-commit supply chains. Right now, this is really when I say pre-commit supply chains, I'm really talking about vulnerabilities or attacks. In this case, really attacks that can happen when that on either the developer machine or in a developer environment of sorts, right? So this is basically we're dealing with either when the developer starts using libraries or when the developer starts using developer centric workflows. It could be git commits, it could be installing a library or using a library or IDE plugins, all of that stuff. So these are some of the scenarios that might come into the picture. There are more, of course, but these are some of the key ones that I have seen out there as well. So you will see that this, again, you have quite a few ways of this happening. It could be through dependency confusion. It could be through a malicious dependency that executes something on the developer machine or the developer environment. It could be infrastructure as code manifests. It could be any of those things. Now, when you look at a supply chain lifecycle, we're dealing with all of this, right? So you have the developer, you have the source artifacts. This is built using some kind of a build system with all the dependencies of that build system into a into an output artifact, which is also your package, and that of course gets shipped to a consumer. Now that package can be an executable, it could be it could be a binary, it could be a container image, it could be what have you, right? So any of this is basically what you would see in a typical, at a high level, what you would see in a typical supply chain cycle. And if you look at it, all of any part of this can be potentially compromised. So if you see what I'm talking about, you're looking at issues at every stage of the life cycle till the point where the package is generated, the output artifact is generated. You have potential for security issues in the supply chain. So any of these things can potentially cause a series of supply chain problems that could have massive implications either within the same cycle or massive implications to the overall product ecosystem and all the underlying users and so on and so forth. So it's quite a large set of issues that we're dealing with. Now, today, the first story that I'm going to talk about is with Terraform, right? Now, Terraform is something that all of you, or not all of you, but at least most of you, are probably using, especially when you're dealing with the cloud, right? So most of us have to deploy resources on the cloud. It could be AWS, it could be Azure, it could be Okta, it could be what have you. You are likely working with Terraform because Terraform is probably one of the most popular infrastructure as code tools for spinning up resources and managing resources on the cloud. Now, Terraform is very powerful because it's basically the one ecosystem that you can use to talk to multiple clouds, right? It's not localized to only one cloud, or it's not specific to one cloud. You can use that to build providers and resources and modules across any cloud or any deployable environment, so to speak, right? So that's something that you see with Terraform. So Terraform really has three things, or three major concepts, or three major terms that you need to understand. You have providers, which is basically the APIs that you need to interact with the cloud environments, right? So AWS is a provider, Azure is a provider, Google Cloud is a provider, Okta is a provider, GitHub is a provider. So these are for these specific cloud environments, right? So these are your plugins to interact with that particular environment, right? So you have providers and you have resources in the provider. I'm going to skip over to resources, where each of your API resources for that particular cloud or that particular environment are created as resources, and you can spin them up. So you can spin up an AWS EC2 server using an AWS instance resource, or you can create an AWS variable or some kind of a parameter using the SSM parameter resource. You can use any of these resources in order to compose your infrastructure as code that ends up actually spinning up those resources on the cloud environment or that target environment that you're using. Of course, one of the things that you also have with Terraform to make things easy is modules, right? Now, modules are basically just a logical container for multiple resources to work with each other. So imagine that I am a developer. I use a lot of Terraform, and I've written this module that makes things easy for people to spin up a Kubernetes cluster on AWS. So instead of learning the whole flow of how to do this, I just create a module and I publish that module, right? Or I give you access to that particular module, or that module is in your internal Git repository, what have you, right? So it could be a logical grouping of resources that somebody could use to generate. Sorry, did oh, I thought someone spoke. My bad. So yeah, so modules are essentially a logical grouping or container where your somebody has written it. So let's say I've AWS EKS. One of the things that I do sometimes is spin up AWS EKS, and EKS with AWS Kubernetes is a little bit of a pain to do. So let's say my colleague has written a module that makes it easy. I just need to call certain variables. I just need to add in certain variables to that, and it spins up the EKS as we need it for the organization. So it's much easier for a lot of us to use modules rather than write our own Terraform from scratch. So think of it like a library for Terraform, if you will, right? So those are modules. Now, when you're dealing with providers, Terraform has considered security quite a bit, right? It's considered these providers are published to the Terraform registry. They are signed with a key and so on and so forth. They have some level of security provided. So you really have multiple types of providers and different level of assurance for those providers. So you have multiple providers like community providers. I can just go on terraform.io and look at all the providers. You will find anyone can submit providers, right? So they will be signed but no additional verification. So if AWS probably is not a community provider because it is official. It's such a critical provider that it's probably managed by HashiCorp itself. But you have any number of people who can create providers who can submit these providers, but they're just signed. There's no additional verification. Then, of course, you have verified providers, which is the second highest level of assurance, where they are verified as, hey, this is who they say they are. That is fine. That's one of the type of providers you have. And of course, you have an official provider, which is not managed by any outside resource. It's managed by HashiCorp themselves. So this is the highest tier of assurance that you will see with Terraform. Now, when you're using Terraform, you're typically, like I said, you have hashes. You also have some level of assurance in terms of the integrity of those packages because they publish hashes, right? So there is something called a directory hash. So each provider is installed in that local environment as a directory, and that directory has a directory hash. And or you also have zip hashes. So all the source code that's downloaded as zips are captured as zip hashes. And this is available in your Terraform lock file, right? So this is available in your Terraform lock file that you can see. And in fact, you can create a Terraform lock file and lock it down and commit it to GitHub repository so that you can actually manage these hashes and ensure that if the hashes don't match, it can actually fail. So you have modes, fail-safe modes like that with your provider hashes. However, today we're going to be talking about modules. Now, modules are some things that you would see that, like I said, it's like a library for Terraform, if you will, right? You can load it from anywhere. You can load it from a local file system. You can load it from a registry. You can load it from another Git repository. There is no concept of verified modules, right? There's no signature, there's no verification, there's none of that stuff. Modules are kind of free range, if you will, right? So that is something that you will see with Terraform modules, and you can leverage Terraform modules to actually perform very, very interesting attacks. And I'm going to show you our first demo around this pretty soon. So yeah, so I'm just going to spin up a lab on AppSec Engineer, and you will see that we will actually do an attack against an AWS environment where we're going to use a malicious module. So the idea here is someone has given me a module and said, hey, this is an awesome new module. Why don't you use it? And that module happens to be a very, very malicious module that does something completely unintended. So let's see how that works. Just waiting for the lab to spin up. Just give me a sec. All right, almost done. So these are labs that we've built in AppSec Engineer. So that's why I'm using it, because it's just easy to spin things up and spin things down. Yeah. So if you now I have, let me explain what's happening here. In the meantime, let me just run some of the, just give me a sec while I pin this to the right place and initialize the environment that I need. Okay. Now, so we have an AWS account. So we're just spinning up an AWS account. So now we have an AWS. So this is a Terraform manifest, if you will. And we're going to be using a module to spin up a random parameter. So we are going to create a random SSM parameter in AWS. So AWS has something called the parameter store in the systems manager service, where you can store variables. It could be secret variables, it could be regular variables. You can store as many variables as you want. So somebody has told me that, hey, there's this awesome module called this random module, and you can literally just pass it a variable name and you're done. You don't have to worry about it. It's all written for you. So this is a module that somebody has given me, or let's say I found it on a Git repository somewhere, or it's published in the Terraform module registry. Now this module, to show you what it's doing something very, very bad. Now, it's creating an AWS SSM parameter. It's creating a secure parameter in AWS, which is an encrypted parameter in AWS. It's generating a random password. All that is perfectly fine. This is what it's supposed to do. But it's actually sending that variable or that password that is getting generated to an attacker controlled URL somewhere. So in this case, I'm using localhost, but imagine that this was some other attacker controlled URL somewhere on the internet. So the idea here is to simulate how this would work. Um, so now let's say that this is the attacker listener and somebody is using this module somewhere on the internet. Now, what I'm going to do is I'm going to deploy. So somebody is using this module, and I'm going to deploy this code. I'm going to use this to deploy my Terraform code to AWS. So I'm going to use this module naturally to do that. And we are going to, so we've initialized it, we're going to apply it. Now, as soon as I apply, it's going to create that parameter in AWS, but unbeknownst to us, it's also going to send that password over to the attacker control listener, right? So it's going to send this password to the attacker control listener. So the attacker now has all the passwords that this module generates. So this, as you can see, can be pretty stealthy, especially because modules tend to be pretty large. And AWS, I mean, if somebody gives you a module, you don't suspect that something like that happens. So, and one of the things you will see with the module is that you can find this with static analysis, right? So if I try and scan it with Chekhov, which is a very popular infrastructure as code static analysis tool, I can find the vulnerability like this is kind of pretty basic, because the vulnerability is right here. You can see that, okay, this is making some random HTTP request. If somebody scans the module, they will find this, but there are ways of bypassing this as well. So you can literally just base 64 encode the payload, and let's see whether our static analysis tool finds this. Let's see whether our static analysis tool finds this now. All I have to do is literally base 64 the payload, and you'll see, hey, it's all good. We've passed. It's great. So you can see that um, even with static analysis, sometimes these things don't get caught unless you are specifically looking for these sort of things. So this is one of the things that we see a lot of people using, because modules are something that a lot of people use with Terraform, right? It's very popular. If you go into Terraform modules, you'll see a ton of modules being published in the registry. Yeah, so you'll see Terraform modules, you'll see like literally a whole bunch of thousands and thousands of modules being published. And it doesn't even need to be published. You can literally pull it from a Git repository. It doesn't need to be published in the registry. You'll see that. So it becomes like installing an app on your phone, which is doing all kinds of crazy things, except it's doing it with your cloud resources. So that is Terraform and how Terraform can be leveraged to do very, very naughty things. So coming to some of the defense possibilities with this. So you can, of course, you can use this. Like I said, how you can do this is pretty straightforward. You can use this particular module, and it can happen. So you can use this module in an environment. You can use. So it may not always be that you're directly using a module, mind you. You could have a provider that is using this module, and it's still going to trigger this flaw. So it's like a nested vulnerability as well, or nested exploit implant mechanism, right? So you can use Terraform containers, cross-build injection, so forced use of the module. All of that is entirely possible. So recommendations: audit your modules. Definitely do some levels of checks. If in fact you can use tools like SemGrep to audit Terraform HCL as well. So HashiCorp has its own config language HCL, which you can use. You have tools to do that. I would recommend also writing some custom, scripts to be able to determine or identify things that you think are risky. It's not perfect, but it's still something that you can do. So the second point really alludes to that, right? Like write SaaS rules to identify possible anomalies. So use of credentials, cryptography, use of base 64 within that particular module or your code base, try and see whether that is happening. The other thing that you should do, especially when you're running this inside CI/CD systems, because most of the time you are using this in CI/CD systems, is you can use hermetic builds. So hermetic builds is where you don't have any egress communication to download something from the CI/CD build machine, right? So you should consider getting to a point where you are building hermetically, where all the dependencies are inside that particular CI runner, and it doesn't make any external calls to build it. That is really, of course, that is a bit of a stretch to get to. It's not always that it's possible immediately, but you should get to that point to do that. So that would be definitely something that I would recommend. And of course, log files. Now, log files are something that you can generate with Terraform, but it's not necessary that it'll solve this problem, but it'll definitely address issues related to potential providers getting switched out or malicious provider related scenarios. It will help. It's not a silver bullet, but it does help to address some of these issues. All right. Not sure if there are any questions or if people. I'm not sure. Let me just continue and probably get to questions after it because. Right. So just give me a sec while I just do the plain window because it's not necessary to crowd up my entire screen. All right. Let's move on to CI attacks, right? When it comes to attacks, so far we looked at a pre-commit supply chain attack, right? Pre-commit is when before the developer has to do, or when the developer is using this to spin up resources or to write code. That's when you have your pre-commit. But then when you start committing and when you start triggering CI jobs, that's when you have attacks against CI as well. In fact, this has become a pretty important issue where you have a new OWASP project. There's a new OWASP project based on an original project from Cider Security called CI/CD Security Top 10. Now I think it's now under OWASP, so it's called the OWASP CI/CD Security Top 10. I highly recommend you look at that. That gives you a lot of interesting detail as to what kind of different attacks can happen against CI/CD systems. They're pretty good, although some of it is a little repetitive. I think two or three could be eliminated, but I think they had made a marketing decision to get to the top 10 list of 10. But definitely useful for you to check out, for you to understand what kind of security issues are with CI/CD and CI systems per se. So one of the very popular CI exploits, especially because of vulnerabilities, either in the way you write CI manifests or you use CI manifests. That's typically how it happens, right? So improper artifact integrity validation. So many times when you are running things in CI, you have steps, right? So CI is nothing. Think of CI like a robot that runs a whole bunch of jobs that do things sequentially, or in some cases also parallelizes these events. Now, it, it uses resources in each and every step. If somebody can taint those resources, then you obviously have a pretty bad thing, right? So any of those resources, the integrity is compromised, or they add something to steal something, or just like in CodeCov, right? So CodeCov was it was a very innocuous attack, because through a Docker image getting compromised, they were able to change a single line in a script that uploaded your code to their environment for code coverage testing. And that single line would just pull all the environment variables from your build environment and push it to the attacker. So that literally was a one line change in a 1800 line bash script. So it obviously is pretty bad at that point. So integrity is a pretty huge issue with CI systems, which is why a lot of the new um, guidance around CI systems is to use hermetic builds, which I already spoke about, is to use hermetic builds, because you are building everything which is self-contained in that particular system that is running the job. So that is one of the ways to avoid some of this. But again, you still need to do integrity checks in CI. So one of the things you'll see a history of this. Of course, the CodeCov thing was one of the big ones. Docker had its own set of issues as well. I'm not sorry, I don't know what's happening here. It should come up here. Weirdly, it is okay. Let me just redo the slide. Yeah. So CodeCov was obviously the big one, but you've seen other ones as well. So if your container images are compromised, somebody can literally commit another container image. In fact, we've seen a lot of attacks where the attackers are going after the container registry, including private container registries. When they compromise, let's say, the registry, they're able to change the container image. And if they're able to change the container image, every single container that runs with that tainted image is now, basically feeding, or it's basically a backdoor for the attackers, right? So, of course, you've seen this with SolarWind with the compromise of the keys and so on. Webmin as well. So this also was where the binary was switched out. I think the hash used in the binary was switched out or something like that. And that's where this happened as well. So this was, yeah, this particular script was changed. So that was basically how it worked. Now I'm going to explain this attack because the demo takes forever to show. So let me explain how this attack worked. And this really was a real world attack that we saw in one of our tests that we've done. And of course, we've also made this a lab in AppSec Engineer. So most of the CI systems, I'm going to be talking about GitLab here, but really this is any CI system, right? It could be GitHub Actions, it could be GitLab, it could be Jenkins, it could be um, Circle CI, whatever, right? It literally could be any CI system. You would see that this behavior is pretty consistent. So in most CI systems, you have the ability to include, right? So include, if those of you familiar with PHP development would probably know the potential for include. Sorry about that. Include is one of those things that can cause quite a bit of issues, but it's also extremely useful from a user feature perspective, right? So include essentially means that instead of you having to write a full CI script and store it somewhere, let's say you have that CI script somewhere in S3 or somewhere else, a publicly accessible URL, whatever it is, you can just include that in your CI specification. So you can say that, okay, execute these steps. Then for the next steps, just include this YAML from elsewhere here and run it as if it were part of the original YAML specification. And this is potentially very, very dangerous, because if that script, which is included in in your CI manifest, is compromised, then you have a huge security issue downstream. So just to give you an idea, uh, we were doing a pen test of an application. The application was hosted on AWS. We compromised the application. Through that, we were able to access the S3 buckets that was hosting, that had files related to that particular application. And in another directory of that S3 bucket, there was this CI manifest. And we realized that this CI manifest belonged to was basically included in all their build jobs. So it was they were using GitLab, and GitLab you can just use include colon and mention a URL that it can access from. So this URL was this particular file that was in this S3 bucket. So we were able, if you just change that particular YAML in that S3 bucket, from that point on, we were able to completely compromise their entire build process on GitLab. So the potential downstream effects of something like this is a huge. It can be really really bad as far as you can see. So this is another attack that you could see with GitLab or with any other CI system. And of course, you can. This is not necessarily only with GitLab. I'm not picking on GitLab or anything like that. I'm just saying that you can do these attacks, and of course many more against CI systems like poison pipeline execution and so on. It is a pretty serious set of attacks that you can perform against CI systems. So again, coming back to some of the recommendations in defense, uh, access control is one of the biggest issues with anything on the cloud or anything even related to CI. In fact, with CI, I would say it's probably worse because people don't seem to understand the nuances of requiring granular access within the CI ecosystem or within that particular CI system itself. So that tends to be a little complicated, and it is also complicated because of the scope of the system, right? You have to secure jobs, you need to secure secrets, you need to secure all of that stuff. So it can get pretty complicated. One of the things that I recommend people do is to look at the SALSA requirements for supply chain security. This is supply chain security levels that have been basically defined in a standard. It's called SALSA. You can find it on salsa.slsa.dev. This essentially has like an ASVS. So if you're familiar with the OWASP ASVS, it has like a level of assurance, kind of an indicator that says that, hey, if you are at this, you're level one. If you do this, you're level two. If you do this, and hermetic builds and all of that stuff, you're level three. So basically, this I think is really good because it kind of requires you to secure your CI system. So although I've never been a big proponent of compliance so much, but I like this because it's actually quite actionable. So it's quite actionable. It's quite usable. In fact, I recently did a talk on Salsa for the GitHub internal security team. So it's definitely worthwhile considering using the Salsa to harden CI or using that as the basis to harden your CI environment. Hermetic builds, like I said, hermetic builds, I am a big proponent of hermetic builds simply because egress, one of the big ways that attackers try and compromise is to send out secrets or pull out variables or pull out other sensitive information. So you might, using hermetic builds, you can reduce this possibility quite a bit, right? So and integrity of the config manifest is very very important. So in your CI system, your config really is the thing that you need to protect, right? Because the config manifest, you don't need to protect it necessarily from a secrecy standpoint, but integrity of that manifest is super, super important. So this, I think, you need to think about when you're dealing with CI systems and validating integrity and not keeping it in some third-party place like an S3 bucket or some other third-party location, and not just blindly using other people's manifests and including it in yours. So that's definitely something that I would not recommend. All right. Moving on, I'm just checking if are there any questions. So just making sure. I'm not sure how many people are on the live stream. All right, moving
No,
on.
there aren't any questions at the moment. So.
Okay, cool. Thanks.
Yeah.
All right. So of course, this is, I think everyone at some point in time, everyone's probably dealing with containers in Kubernetes, whether you want to or not. So this is an ecosystem that is quite large, naturally from an operational standpoint, and consequently from a security standpoint as well, right? Because it has that many moving parts, you have a pretty large ecosystem. So when you're looking at containers in Kubernetes, you're dealing with a lot of things. You're dealing with container images, you're dealing with GitOps tools, you're dealing with Git repositories, you're dealing with the container image itself, you're dealing with the built container, you're dealing with container registry where these images are stored and managed. Once from the registry, of course, it gets deployed to Kubernetes, and that has its own set of supply chain considerations. Like it has webhooks, it has manifests, it has operators, it has service meshes. All of these things are supply chain, right? All of these things really constitute your supply chain, because you have to deal with securing all this. It tends to get a little overwhelming unless you understand the ecosystem and start to take action. You can't obviously take action immediately. It does take some time for you to establish some level of competence in these areas, but these are things that you have to consider. So if you just look at the network plugins and so on, so if you look at the supply chain considerations here, you'll see that there are quite a few, right? It could be uh, from container registry. I'm just waiting for the attack stuff to show up. So, the base image, the code in the layers, the secrets in the container image, if any, authentication to the container registry, authentication based on these GitOps tools, the runtime config, the user authentication when it's running the container, the volumes, the network. Oops, I'm so sorry about that. One missed mouse click and everything kind of goes away. Sorry about that. Yeah. So of course, container registry has its own set of issues. In fact, container registry, I would say, is perhaps one of the most underrated attack possibilities, because most people, I don't know why they don't look at container registries. A lot of them are really badly configured. Uh, there is a lot you can do with container registry, so it's pretty interesting the kind of stuff that you can do, especially with once you establish some kind of an authenticated presence on a container registry, you can literally start to expand your access pretty quickly. This is where all the images are stored and managed. You can do a lot of stuff with container registry. Now, the thing I'm going to be talking about today is, of course, not container registry. I'm going to be talking about Kubernetes. Now, one of the things that a pretty big part of Kubernetes is Kubernetes admission controllers. Now, Kubernetes admission controllers are basically like customs inspection, right, in an airport. Now, let's talk about what that means. So, if you look at, I use this airport analogy always for admission controller. So, let me talk about this from an airport standpoint, right? So, you have a passport, and that's basically a validation of your identity as a citizen of a country, right? So, passport is authentication. And once you have a visa to a country, so let's say you need to visit some country, you need to have visa, you need to have some kind of authorization to visit that country. So you have a visa, so that is authorization. But once you clear passport control, you just can't bring anything you want into that country, right? You can't carry contraband and stuff like that into that country. So that's admission control. So basically, customs is admission control. In Kubernetes, the same concept is admission control. So you have authentication, you have authorization, but outside of that, once authentication and authorization is done, that's when Kubernetes kicks into the picture with admission control. Now, admission control essentially is a set of configurable policies where you can decide that, hey, I want to load only container images from this container registry. That is in form of admission control. Or I want to load containers that are only configured with non-root conditions. That is also admission control. Or anything. You can literally extend this to anything. It could be, I need the labels to be consistent with my Kubernetes deployment. That is also admission control. Now, all of this is basically examples of admission control. And one of the things with Kubernetes, with the ecosystem, the way it works is that admission control is extremely configurable. You can write your own admission control, right? So you can create, these are called dynamic admission controllers. You can write two types of admission controllers. You can write either validating admission controls or mutating admission controls. Now, these are written like webhooks, right? So basically, you write a web application or a web service that receives, So the Kubernetes API server would initially send this web application that you've written the request and says, "Hey, can I load this in the cluster? Just tell me whether it's allowed or denied." That is a validating admission control. Or it says that, hey, this is somebody is trying to load this or create this deployment in my environment. Do you need to change anything? Do you need me to validate anything? It sends it to you. And let's say you change that original request to conform to your cluster's policies. That then you are creating a mutating admission control. So validating just checks whether it is right or wrong. It denies it if it's wrong, allows it if it's right. Mutating changes the nature of the original request and makes it into a different thing based on whether it triggers your rules and so on, right? So that's basically admission control. And you can create any level of admission control, right? So validating admission control or validating webhook is basically the API server sends a request to uh, your API, your web. You've configured this admission control, and you say that okay, I'm every time an API server sends this request, you check whether it is as per your policies, and if it is as per the policies, you say yes or no, and then you persist it in the Kubernetes database, which is at CD. Or you could mutate it. So there's the request that comes in, you change the nature of the request to suit what is in your policy, and then you check it, you validate it, and then it goes and the request is actually fulfilled, right? So that's basically how it works. So you can configure admission controls on the type of operation, on the types of resource loaded, on the namespace that you're loading it. You can do a whole bunch of things with admission control, right? So yeah, there are some things that you need for this to work. You need to write a web service, a webhook that needs to be enabled. You need to have TLS certificates because literally everything in Kubernetes is TLS certificates. You need to have the right certificate that is signed by the cluster for the cluster to interact with it securely. And that's basically how it works. So in this case, you will see that this is validating admission control that is operational whenever a pod is created in this namespace called the webhook namespace. So every time a new pod is created in this namespace, that's when this admission controller is invoked, right? So that's the configuration that we are talking about here. So if your validating admission controller works correctly, then you have it's an allowed response. It says true, I allow it. If it's not, it says no, denied, I deny it. So all of these are type admission review, which means that based on the review of the policy, either allows it or denies it. And it also gives you, you might add additional context to say that, yeah, this does not contain. So for instance, in this case, it is deny. And the reason is that it does not contain a valid label. So literally, you can have any kind of policy that you can set up in a Kubernetes cluster. You also have a mutating admission control, like I said, where you can change the nature of the original request. So the original request is X, you can change X plus Y becomes Z, and that Z is what gets pushed out to the the Kubernetes cluster. So it essentially creates a patch on the original request and deploys that patch into as the final request into the Kubernetes cluster. So again, as you can see, this is a very, very powerful ecosystem, very, very high privilege ecosystem. So if you can compromise a Kubernetes cluster, then you can install your own validating admission controllers or mutating admission controllers that can steal keys, that can change requests, that can add backdoors. You can do pretty much anything. So this is a huge, huge issue for clusters, right? So again, this is an issue that you will see. If your cluster is compromised, one of the major post-exploit scenarios with Kubernetes in mind is installing admission controllers. This is a huge issue that can have massive impacts and consequences, right? So this is something. So I'm going to show you a demo of this. Hopefully, it looks like my demo just uh, just give me a sec while I pull up the demo. I need to restart the demo. Just give me a sec. While I do that, I was hoping to not have to restart the whole demo because it is a large demo, but looks like I have to do that. I think I started it too early just before the session started, and I think it expired. Just give me a sec while I do that. So this is another lab on Kubernetes admission control compromise. So I think I'm going to take up the rest of the 10 minutes just walking you through this demo.
Sure, that works for us. And while we're setting up, are there any questions for anybody out there?
Yes.
Because now will be a great time to answer them. Yeah, sorry, it's been a bit quiet in the chat, but
All right.
okay.
All right. Looks like we have server access. Just going to. So I need to, yeah. So this, I'm going to spin up a new Kubernetes cluster from scratch. Just give me a sec. It is going to take a little bit of time, but yeah, I was hoping that the server would be up, but yeah, anyway, it's fine. So I'm just spinning up a new Kubernetes cluster, and we are going to deploy an app, right? So the way this attack is going to work is I'm going to spin up a new cluster and I'm going to deploy an app to that cluster. This app is vulnerable to an injection flaw, a server side template injection flaw. And I'm going to use that. So, as an attacker, I'm going to use that flaw. I'm going to compromise the app. I'm going to pull up the service account token from the Kubernetes cluster. So, every Kubernetes cluster, if you don't configure it not to, it will inject the service account token into the pod of the container that you're running. And you can, if you are able to somehow get access to that service account token, you can use that to compromise, gain higher privileges on the Kubernetes cluster, maybe. So in this case, you will be able to do that. So we're going to privilege escalate to the cluster. Once we privilege escalate to the cluster, we are going to install an admission controller, which is going to steal secrets. So any secrets that are going to be loaded in my cluster, my admission controller is going to pretend to do some validation, but it's not doing any validation. It's essentially just stealing secrets and pushing that to an attacker controlled listener out on the big bad internet somewhere. So just waiting for this to start. This does take a little bit of time. My apologies. I had tried to optimize it by starting it, but I think I started it too early. And just waiting for this to spin up. So I'm going to show you the example with the validation admission controller. I'm not going to show the mutation one because that would take a little bit longer. Right. So it's just deploying all of the stuff that we need um, for our cluster to work. Just waiting for the final bits of this to be done, and then I can actually get into action mode and show you how this works. Not sure how many of you do Kubernetes work, but if you are, this is something that you should definitely think about. Looks like our node is ready. So I'm going to start deploying our app. So I'm going to deploy our app to the cluster. This is a Node.js app. And this app is going to get deployed to the cluster, and I'm going to start checking whether the app is up, first of all. Just waiting for the app to run, and then we are going to access the app and compromise the app. So it's actually, so the idea here is that we go from being a complete unknown or a complete random person on the internet to be able to completely control the Kubernetes cluster. So that's how this attack is going to work. So I'm just going to, I need the app name so that I can access it on a particular port. I'm just port forwarding it. I'm just doing, this is not a live, I mean, I'm not a production instance, if you will. This is just a very simple app that I've deployed. So that's why I'm doing this port forwarding. You would normally not do port forwarding, but that doesn't change any of the dynamics of the attack, so to speak. So now I can access the app on port 5000. It says, hey, you're on AppSec bookstore, blah, 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 etc., etc., etc. Right. So now we are going to exploit a certain vulnerability. So AppSec Bookstore, unfortunately, does not handle error codes very well or errors very well. The reason is that when I just give it some random page name, it says I'm unable to find it. This is fine. But if I evaluate an expression using, yeah, a mathematical expression using template this template syntax, let's see what happens. So if I do this, unable to find 49. So clearly means that this expression is evaluated on the server side. And this is great because with this expression, we are going to do some very, very interesting things. Now, we are going to use a tool called TPL map. Anyone heard of TPL map here? Not sure if anyone has heard of TPL map. This is a tool like SQL map, oldie but goodie, that does template injection. So TPL map does template injection, and we're going to use that to try and exploit our template injection. So, oops, sorry, wrong URL. So you just need to give it a URL and it will try and start exploiting URL. So it says, yeah, I'm checking. Yeah, you can. I can exploit it. You're using the Nunjuck's templating language, Nunjuck templating system. I can do that. I can give you a reversal. I can give you a file read. I can give you a file write. I can do pretty much anything. This is great. Awesome. So now what we are going to do is we're going to do a very specific thing. We're not going to do too much with it. We're just going to pull out a service account token. So every Kubernetes pod, there is a, unless you configure it otherwise, there is a service account token that is injected into that pod, right? Or injected into that container of that pod. Now, that service account token, if it is a high privilege service account token, then somebody can use that token and access your Kubernetes cluster with that privilege. Whatever the privilege that has been assigned to that particular token, that somebody can use it to, if they find it, they're able to use that and start to do very interesting things with it. And this token, no prizes for guessing, has a lot of privileges. So we're going to get this, and you can see this service account token is now pulled out by just catting that particular file. I'm going to export it as a variable so that I don't have to do too much typing. I hate typing. So let's start to access the cluster with this token's credentials. I'm going to set this as the credentials, and I am going to start accessing the cluster. So I'm going to say blah, blah, blah. Okay, so I'm going to set the context. This is just basically me getting it set up to access as this particular uh, compromised token user, right? So this is, yeah. So now what I'm going to do is I'm going to, instead of trying to steal stuff and all of that stuff, I'm going to install a permanent backdoor in my Kubernetes cluster. So what I'm going to do is I'm going to install a validating admission controller. Now this validating admission controller does some very, very nasty things. So what this does is that it essentially just, as soon as it finds a string, it just pulls that. I don't think this is the right code base for that, but nevertheless it works just fine. So what this validating admission controller does is that it pulls the, see, if it finds a secret in or an environment variable in any of the container manifests, it's going to pull that and actually push that to an attacker control listener somewhere, right? So I'm going to do that. So I just need to make a few config changes to the, so I'm going to first deploy the admission controller, and I need a TLS certificate package to do that, and then I need to install the actual deployment, and then I'm also going to deploy the service. So all of this allows me to set up my admission controller. So at this particular point in time, I am running a full-fledged admission controller that, yeah, so every time a new deployment is created, it is going to pass through my admission controller and it'll go through this particular webhook API endpoint, and it's pretending to be validating something, but it doesn't validate anything. It just literally is there for stealing secrets. That's basically why it exists. So it's not validating anything, right? So now I am going to spin up my attacker control listener. So imagine that this is an attacker control listener somewhere on the internet. This is the listener. Oh, sorry. Somewhere on the internet. I'm going to spin up the listener, and I'm going to, and some, you know, some Kubernetes developer or somebody managing the Kubernetes cluster is going to deploy this Nginx deployment on Kubernetes. So unbeknownst to them, they're just going to install it and they're going to provide some environment variables. And these environment variables obviously are very juicy. So let's see what happens. So now I'm going to deploy it in my cluster. Hopefully my it's running. As soon as I deploy it, now the thing that is going to happen at this point is it's first going to go to the API server. The API server is going to go to my validating admission controller, check if everything is okay, and only then deploy it. But my validating admission controller, like I said, is not really validating anything. It's just basically stealing environment variables. So as soon as I do this, it says, yes, I've created your deployment, but the listener gets this. So the validating admission controller very simply just starts to take things out, pull it. Of course, you can see that the possibilities for this is endless, right? You can even and if you can do mutating, it's even better because you can install a permanent backdoor, you can change network traffic, you can change the etc host file, you can do anything you want. It's really quite a large attack scope at this particular point in time. So this again, one of the things with this, one of the I think probably the only ways to do this is to really focus on role-based access control. To defend against this is really focus on role-based access control in your cluster, and to ensure that any admission controller is obviously not added by somebody without access. So that is something that you need to ensure that, yeah, again, that also comes back to role-based access control. But this is a very powerful way to establish like a permanent backdoor on your Kubernetes cluster. Yeah, so that's basically what this is. Any questions at this point? Because I'm done with my talk. I'm happy to take any questions. If you do have any questions, I'll be happy to take them at this point.
I do not see anything in the chat, but there is. We can solve for a few minutes. So, if anybody does have any questions, do you have like a last page or a slide or anything with contact information?
Yes. You can just the best way to reach me is on Twitter or LinkedIn.
Yeah.
And my
Just right there
Twitter
on the screen.
handles are right here, so you can
Perfect.
follow us, reach out to us. We have a pretty well subscribed to YouTube channel as well. We keep putting out content like this there as well. So if you're interested, you can check out AppSec Engineer on YouTube, and that's a pretty well watched channel as well. I'm just going to. I think I have a slide with this. No, I don't. Sorry about that. Yeah.
Yeah, so it looks like we just have one comment, not a question, from Mitch, where he's talking about setting the SHA-256 digest.
Yeah.
Yeah.
Yes.
But yeah, so no further questions. I just wanted to take the time to thank you again for coming in and giving us this talk. The supply chain is always a fun thing for me to test as the attacker mindset, because there are a lot of goodies that I can get in there if I can get any control of the Git or any kind of developmental level access. So yeah, this is definitely good because I do always like when my job gets harder. It means that the systems are getting more secure and we are collectively getting better. So that is the end goal. And yeah, I just want to say thank you for coming in and giving us this talk virtually. I know we would have liked to do it in person, but it just didn't work out with our schedules. You were in town.
No, that's fine.
Whatever. Yeah, sorry, we couldn't get a physical location up and ready to go. But yeah, again, thank you, and I'll keep you posted, everyone else, on May's upcoming event. We have some speakers lined up, so we're trying to get everything lined up again, and we might be able to do it in person, but that might just need to be pushed back till June. And again, October 30th and 31st is the OWASP DC conference. So if you want, just go to, let me pull that up really, really quickly while I'm stalling for time. So we got the OWASP Perfect. So let me just put this in the chat. dc.globalappsec.org. So there's more information there on the upcoming conference, the 30th and 31st. And then there's training the following 3 days, the 1st to the 3rd. And so, yeah, I hope you all have a great night, and we will see you next time. So take care.
Thanks so much. Bye-bye.